Hi, I'm Gloria. I told him to say tuning performance with machine learning, so it's not fine tuning. Um, so I'm Gloria, and today I'm going to be telling you about a service that we're working at Twitter on the Java Virtual Machine team called AutoTune. And AutoTune tunes performance with Bayesian optimization. And I'll get into what that means later, but first I'll tell you a little more about myself. So I'm a software engineer at Twitter, and where I've been working on this service. And in my free time, I'm basically constantly browsing Twitter, because since I work there, I need to plug my handle a little bit. Feel free to follow me at One and Only Glow. I sometimes tweet about tech, sometimes not about tech, just random funny things. And to give you an idea of the structure of this talk, I'm first gonna tell you about the problem we're trying to solve with AutoTune and why we're trying to solve it, and then give you a little more context. And then I'll explain how Bayesian optimization works with respect to AutoTune, run through some examples, explain how we use it, and give you an overview of its architecture. I'll then wrap it up with some results, interesting challenges, and some future work that could be done. To give you some background, Twitter is composed of microservices. There are over 1,000 running to keep Twitter afloat. Basically, everything is a service. So some are things you'd expect to be at Twitter, like our tweet service, users, notification service. Those are a little more user-facing, and there's also others that deal with Twitter running underneath all of that. So like our infrastructure, data, storage, and routing. And there's even services that deal with tuning services like AutoTune. And while we have over 1,000 services, there's also hundreds to thousands of instances running for each service. So this image is kind of a visualization of what our service graph could look like with a lot of services, and a request could travel through many services before being complete. So with a complex system like this, it's pretty important that each service is working and working efficiently, which brings us to the topic of today, which is efficiency. We want to improve performance and in this way make services more efficient. Oops. Why do we care? At Twitter scale, every bit of performance improvement matters. Improving efficiency saves money, and the dollars really add up. Making services more efficient means we can have less instances running, and less instances running, we can have less instances running while accomplishing the same amount of stuff. So this means less physical machines, and that's where we save money. Even an improvement of a few percent can add up to a lot. So I can't quote dollars publicly, but the costs of running Twitter are very high. And for a random example, if it costs $100 million to run Twitter, an improvement of a few percent would still be savings of $3 million. And saving money here means putting it where it counts, which is why it's important to engineers at Twitter working in all areas and on all layers of the Twitter stack. So this is what the Twitter stack looks like. We have a service running on top of our JVM, so an instance of our JVM, which is running on our kernel, and that's running on top of the hardware in the data centers. And I say JVM because most of our services are written in Scala, some in Java, so most things are running on the JVM. So as you can see in this visualization, each layer has its own parameters, which is another way of saying like different configurations that you can adjust. And the number of potential parameter configurations multiplies with each level. So all those times the kernel parameters, times the hardware parameters, that ends up being a lot. And the function of the performance of a service ends up being a function of all of these. While not all parameters affect performance, a lot of them could. So adjusting some might improve things, and adjusting others can make things crash and burn. And maybe adjusting one improves things, but when you adjust it in conjunction with another, things crash and burn. So you can see how this gets complicated pretty quickly. And since we were talking about performance tuning, how could we possibly tune all of these parameters? That seems pretty hard. So we have to start somewhere. So being the JVM team, we decided to focus on the JVM parameters. Whoa. Go back. Don't look. Okay, so there are hundreds of JVM parameters. There's around 200 tunable parameters for the Twitter JVM that affect performance, and for the most important ones, it's around 20 to 50. And since I'm not a JVM performance expert, I can't tell you all of them, but just to give you an idea, I threw a bunch up on the slide. Some are related to memory, so these can help with out-of-memory errors or other memory issues. There's also parameters for tuning garbage collection, so these are maybe for using different garbage collectors or different amount of threads running, different sizes, and there's also other parameters related to CPU usage and a ton of other stuff. So you get the idea, there's a lot, and it's extremely difficult to tune all these parameters. And before auto-tune, hand tuning it was our best bet. So the current flow, or the workflow is something like this. So up there we have the service owner who wants to improve the performance of their Twitter microservice. They come to a JVM performance engineer. Usually they ping them on Slack or file a ticket, and the JVM engineer thinks about it with intuition over 15 years of working on the JVM and comes up with a set of parameters that they think the service owner should try. So then over there is our job scheduler, Aurora, which just remember the symbol because I'll use it a little more later, but it basically takes care of all the steps necessary to restart, roll back, start an instance with like a parameter configuration that you can give it. So now that the service owner has it, they try it, and they take some metrics and see if they like the result, and they just kind of keep iterating through this until a good solution is found. And this doesn't really scale, especially when you think about how many services we have. I said there's over 1,000, and how many JVM engineers we have. I think the JVM team at Twitter is around 10 people right now, and not all are performance engineers. So ideally, we'd like to decrease the amount of support needed from these performance engineers, freeing up their time to do other work, and also decrease work on the service owner side. So this whole manual process kind of has a lot of overhead. They have to wait on the JVM engineer to come back to them. It's very time-consuming and uses up a lot of engineering time. And there's also, the other goal is also to be continuously tuning. So there's updates and refreshes to each layer and in the data center. So maybe you find the optimal settings now, but quickly the churn makes it obsolete. So we need to be constantly iterating to find the ideal settings. So I mentioned this is a pretty expensive process. What if we could automate all of this and remove some of the manual work from this equation? So this is the new workflow we have with AutoTune. The performance engineer is now supervising the whole process instead of generating the configurations themselves. This frees up their work to go do other things, and also frees up the service owner's time. And this is how it could look like. Maybe they could be tuning multiple services at once, and other service owners tuning multiple services. So this is obviously a lot cleaner and more efficient than our previous workflow. So the auto part of AutoTune is driven by a process called Bayesian optimization. And lucky for us, AutoTune doesn't have to do that part itself. It leverages an existing Twitter service called WetLab as our machine learning and Bayesian optimization backend. And before diving into that, I'll introduce some terminology that will be helpful in understanding. So the first thing to make clear is what exactly are we optimizing? And in Bayesian optimization terms, it's called the objective function, which we can call F for clarity. And in AutoTune, this is the service performance. And this can be, it can be a lot of things, but an example of what it could be is maybe measuring CPU utilization. So if we have a function f, what would be the x of the f of x? And in our case, this would be JVM parameter values, which is all the JVM parameter values I was showing you before. An example of one could be number of parallel garbage collection threads. And another helpful terminology is evaluating the objective function. So evaluating the objective function is like producing the result. And in our case, what an evaluation would look like is starting up an instance of our service and taking some metrics. So for example, say you decide the objective function f is CPU utilization, and the x that you're putting in is maybe number of garbage collection threads equals 5. So you start up the instance with that configuration, and as the evaluation is running, you take an integral of the CPU utilization across time, and you end up with a scalar value. And just for clarity example, we can say ends up with 72. So evaluating the objective function gives you like a number, and this is how we determine whether it was good or bad. And we're trying to find the value of x that produces the highest f of x. And the goal is like to find the highest value. And so how do we do this? And one way of finding the optimal is brute forcing it. So evaluating every value of x, and in multiple dimensions, this is something called grid search. So you're basically searching all the possible possibilities. But evaluating the objective function is pretty expensive and costly in money and engineering time. So to do this in the most efficient way, we try to evaluate the objective function as few times as possible. So what about maybe using some kind of linear regression or trying to use what we know about performance functions to try to find the optimal? This doesn't really work because we have no idea what the performance function looks like. It's a black box function, which means we have no idea anything about it. So it could have a pattern, it could not have a pattern, it could be anything. So the systems involved in running a service are pretty complex, and going back to the layers picture, all the parameters, we don't know what parameter affects what, and even at the JVM level, it's equally complex. And the example I gave earlier, the f of 5 equals 72, is just one dimension, so tuning one parameter at a time. There's around 50 important JVM parameters that could be tuned simultaneously. And luckily for us, Bayesian optimization is well suited for our purposes. It's well suited for situations where the objective function is expensive to evaluate, and also when dealing with many dimensions, or our Bayesian optimization backend can deal with up to 30 to 40 parameters. And a picture is worth 1,000 words, so let's get into how it works with a visual. So there's a lot to unpack in this slide. Just to be clear, the x-axis is the parameter that we were talking about before, the 5, and the y-axis is some measure of performance, and we're assuming higher is better. So this dotted line is the black box function f that we're trying to optimize, or we're trying to find, and it's actually unknown, but just shown on this graph for clarity. And Bayesian optimization figures this out using two main components. The first component is our statistical model, which is usually a GP, and that's basically where it thinks the value of f is, and the shading is the variability. The second part is the acquisition function. So this function tells us where to sample next. So for example, there you see the value of the acquisition function is 0, And you see that lines up with the top with a point you've already sampled. So you've sampled that point, so sampling that again would give you nothing. And at the bottom, you see that's the highest value, and in the corresponding top graph, you see that that's also the currently what it thinks the highest value is. So it takes into account what it has seen and what it doesn't know to generate that bottom graph. So now I'll run through an example to make it a little more clear. So that's the highest point, and you select that and update both graphs. And then you go again. And select the highest point again, and you keep iterating. Yeah, so you keep going until you found the optimal point. And for the people that understand better for when they look at code, here's some pseudocode that might help you understand. You do some initialization work, which is placing an initial GP on F, and since you don't have much information, that could be anything, just like a flat line. And then you evaluate F at a certain number of points, and you go through this loop until the optimal is found. So you update the probability distributions with all the available data, and then you sample the next point, and repeat. So now that we've nailed down how Bayesian optimization works, I'll show you some details about how we actually use AutoTune. So this is how our ML dashboard looks like, and it's the equivalent of what we were looking at earlier, just how it actually looks like when we're looking at it. You can see that green point up there with the purple arrow is the optimal that ends up being found. And some more horrible-looking JSON. That's how the service owners interact with AutoTune currently. So AutoTune, you start up an experiment with AutoTune, and within the experiment are many evaluations. And in this JSON, you can specify what parameters you're trying to tune and the min and max value of those. And you also specify the objective query that you're trying to optimize for, and also how long you want the experiments to run. And another key piece, and also how many instances you want to experiment on. So with every evaluation, it picks a control instance and an experimental instance and uses the experimental configurations on the experimental one, and then it compares the results using the control. So one last thing about AutoTune specifics is you can also specify constraints that you want on the tuning process. So sometimes poor configurations are generated, and it's basically crashing and burning, and you want to terminate it as quickly as possible before it affects the service's performance as a whole. And constraints that are specified by the user are monitored by our observability system, and when any are violated, the instance is rolled back. So our observability system is an internal Twitter system that tracks metrics for everything, including all Twitter services. So examples of constraints could be success rate, keeping success rates of incoming requests above a certain number, and response time latency less than a certain threshold. And not only is the instance rolled back, our machine learning backend also learns these constraints by seeing which instances it started that were terminated. And without these constraints, the evaluations kind of become pointless. So if you're trying to optimize for like minimum amount of CPUs throttled, the service could just do nothing, and they would call that a successful evaluation. But you want to set constraints on it, like the success rate of the incoming requests is still above a certain number. So constraints are an important part of the puzzle. And so here's an overview, just so you can see how it all comes together. So AutoTune is in the middle, communicating with our with WetLab, which is our Bayesian optimization backend, and storing our evaluations and experiments in our storage, and also communicating with our job scheduler to actually deploy those services. And observability is just in there, measuring the constraints and measuring the objective function as well. So the moment you've all been waiting for, results. Does this even actually work? And yes, it does. So we ran this with our biggest services, which are our tweet service and our user service, which we affectionately call Tweety Pie and Gizmo Duck, and we found improvements of 7% and 8%. So like I mentioned before, even a few percent is a lot. So 7 to 8% is a pretty big win. And to wrap things up, I'll get into some challenges we faced, some future work that could be done. So some challenges we faced originally when we ran auto-tune experiments on services in our staging environment, and we found that those configurations, when applied to production instances, we didn't get the same performance gains that we saw in testing. So it turns out traffic patterns in the staging environment are very different from the production environment, and configurations for one aren't optimal for the other. And the solution was to run experiments on production instances. Another interesting thing we ran into was we found that a lot of times seemingly good configurations were getting terminated and marked as bad. And we found that it was because during the startup process for an instance, all those procedures and initialization caused some spikes that violated constraints. And so our solution was to set a certain time at the beginning of the experiment to ignore the constraints that we've set. Okay. And some future work that we could do, you might have noticed that I kind of glossed over like the experiment stops when we found a good enough result. And right now, it's just kind of up to the user to determine when is good enough and when they want to stop. And I think eventually we want to work on a more unified completion criteria of when to stop. And a long-term goal is just total automation of the whole process. So right now, the parameter configuration tuning part is automated, but eventually it could be nice to have, even once you find the optimal parameter configuration, that's applied to production settings, and then the service owner doesn't have to do anything. So some credits. Sitting picture is my hero, Arya, and Ramki Ramakrishna and Jin Chao Lu for coming up with this idea to tune service performance with Bayesian optimization, and also the Twitter VM team for all their support, and also our Bayesop backend WetLab. Thanks for listening.
Gloria, sorry for introducing it wrong.
That's okay.
We've got lots of time left, so that means lots of questions. You ready? You're
Yeah.
going to read, you're going to answer. I do that same thing every time and no one laughs anymore. How do you handle noise in performance measurements in your Bayesian optimization?
So that's one of the things that we could potentially improve upon, but right now we're using the length of the evaluation, so we let it run for longer to let the noise kind of balance itself out, and that's been working so far, but eventually we could think of better ways to deal with noise.
Is auto-tune going to be open sourced?
That was kind of on the horizon. I think there's some legal stuff that also has to be done for things to be open source, but potentially.
Did you try an evolutionary program for finding the best parameters instead of Bayesian approach?
I'm not sure what evolutionary programming is, so I can't answer that.
Okay, I have no idea. Are there any known cases when auto-tune cannot be used or doesn't provide valuable results? If so, what are these cases?
I'm sure there are cases where it can't be used. I can't think of any ones right now.
Cool. What programming languages are most popular at Twitter?
Scala is our biggest language, so most people use Scala.
How do you measure performance? I guess that's you. No, it's gone down. How do you measure performance?
Me personally, I mean, it depends. It depends on the situation. So sometimes we measure, like I mentioned, CPU utilization. Sometimes we measure success rate. So there's a lot of different factors.
How complex would it be to tune all the parameters, services, JVM, kernel, HW? Huh?
That would probably be extremely complex.
I'm loving these short answers. We're rattling through these. Next. How do you encourage teams to auto-tune their services? This is one more thing a team has to do. Are services compared to highlight the inefficient ones?
So right now at Twitter, we're not like forcing people to use autotune, but actually a lot of teams come to us saying like, can we use autotune for our services? Because they see like the gains that other teams have had and success other teams have had using autotune. So right now it's more of like, if someone's interested, they come to us.
Are those saving calculations included the cost of running autotune?
I don't think so, but the costs of running autotune are probably a lot lower.
Why was it more practical to run experiments on production environment rather than staging? Did that raise issues concerning user data privacy, thinking of GDPR?
So we ran them in production because we wanted the traffic patterns to be more similar. With the GDPR stuff, GDPR is like a big thing at Twitter because we operate internationally. I'm not sure the best answer to that question, but we weren't using actual production traffic. We were using a copy, and it wasn't actually sending stuff out. So yeah, that's my best answer.
Cool. Do the optimal parameters change with time? Does autotune have to be rerun manually in that case?
Yeah, they probably do change with time. Right now, you kind of pick the parameters you want to focus on, and then you can pick different ones at any time.
Okay. Do you still want to do more?
I don't care.
If you're tired and you've had enough, it's okay to say so.
I'm going to do like a couple more.
A couple more. Okay, great. What stack tech does autotune run on? Have you tried auto-tuning? Autotune.
So
Nice
that's
one,
actually a good. So when I was an intern on this team, I asked them, "Have you ever tried auto-tuning autotune?" as a joke, and then they like gave me this super long explanation about how that wouldn't really help. I don't remember the explanation, but
So the answer is become an intern and you'll find out?
yes, exactly.
Good answer. What about other virtual machines? Node, .NET. Do you use them? How do you optimize it if yes?
Some other teams might be using those. I'm not sure, but I'm sure there's ways to optimize them.
Okay, this will be our last one. Do you plan to tune the internal parameters of the services?
I think that could be a possibility. Autotune just focuses on the JVM layer of
Cool.
parameters.
Big round of applause for Gloria for answering so many questions.